Alright, in the last section we worked on adding and subtracting rational expressions, so let's just do a little quick review of that before we go on any further. So let's look at 5/6 plus 1/9. In order for us to add these fractions together, we need a common denominator. So between 6 and 9, our common denominator would be 18. That'd be the smallest thing that both 6 and 9 will go into. Now, what do we have to multiply the 6 by in order to turn it into an 18? We'd have to multiply by 3. So we're going to have to do the exact same thing to the top to keep that balanced. So our new numerator then would be 15. Now we're going to do the same thing with the second fraction. So 9 times 2 would give us 18. So we have to do the exact same thing to the top. 1 times 2 would be 2. And now we can go ahead and add those fractions together. So that would be 15 plus 2 over 18, which would be 17 over 18. Okay. Now let's review a subtraction one. So here we have 5/2 minus 3/8. So again, we need a common denominator. And between 2 and 8, the common denominator would be 8. That would be the smallest thing that they will both multiply into. So now let's see, what do we have to multiply the 2 by to turn it into an 8? That would be a 4, so we have to do the exact same thing to the top. 5 times 4 would be 20, minus, to change 3/8, well, 3/8 is already over that common denominator, so we really don't have to do anything to it. But now that we have a common denominator, we can work with the numerators. So that would be 20 minus 3 all over 8, which simplifies into 17 over 8. Alright, so we've talked about how to add fractions and how to subtract fractions. But now, what happens if we have something like this? Here we have what looks like a very complex fraction, which that's exactly where it gets its name. These are complex rational expressions. But let's look at this. Here is our numerator in this gigantic fraction. And here is our denominator in this gigantic fraction. So 5/6 plus 1/9, we just did that problem. If you'll remember, that was 17 over 18. And then 5/2 minus 3/8, we just did that problem also. That was 17 over 8. Now, even though this looks very scary, this is just a fraction over a fraction. And remember, a giant fraction is just another way of saying a division problem. So I could really write this out as a division problem. I could write it as 17/18 divided by 17/8. And now our normal fraction rules take over, because we never divide by a fraction. Instead, we change it to a multiplication and flip that second item. So that would be times 8 over 17. And now again, continuing on with our regular fraction rules. We can cancel any top with any bottom, any numerator with any denominator. So our 17s will cancel each other out. 17 over 17 is 1. And looking at the 8 and the 18, well, they both have a 2 in common. 2 goes into 8 4 times, and 2 goes into 18 9 times. So when we simplify this, we're left with 4 over 9. This is the exact same procedure that we're going to use whenever these things start getting more and more complex.